Hello everyone, today we are here with Raymond Najjar, one of our clinician scientists, a neuroscientist actually, who has an interest in myopia, a very common problem in Singapore. Raymond, what's myopia? What's your team been doing and why is it important?
Thank you, Audrey. So it's a pleasure to be here with you, and thanks a lot for having me. My team has been indeed interested in myopia for the past 5 years, but more specifically to how light can actually impact the development of the eye and the development of myopia. So in the past few years, we were interested in how the spectrum of light can affect ocular growth and the development of myopia. And we published this paper in 2022 in IOVS that shows that actually the distribution of the spectrum of indoor light can affect the emmetropization process. So first, I would like to thank the team who actually worked on this publication, Dr. Murali Duran, Leong Chong, and Shermaine, and of course this is a collaboration with Seoul Semiconductor, between SERI and Seoul Semiconductor, and this wouldn't have been possible without the experimental medicine.
Okay, so Raymond, can you maybe tell us about what is emmetropization, myopia, and why it's important?
Okay, so emmetropization is actually a gradual phenomenon that occurs after birth. It's a phenomenon that ensures that eye growth is harmonized with the focal power of the components of the eye, so that the image is formed on the retina. And once, as you know, once the image is formed on the retina, we can see the world clearly. However, when there's a problem with this emmetropization phenomenon, for the eye, for example, keeps growing faster than at its normal rate, then the image is formed in front of the retina, and then the images would appear blur, and this is what we get with myopia.
Myopia, which is the common condition we have in Singapore.
This is indeed a very common condition that we have in Singapore, but also all around the world. In fact, myopia affects over 2 billion individuals worldwide. It's, as you mentioned, of epidemic magnitudes in several parts of Asia, including in Singapore, and it's projected or it's predicted to affect over half of the population and be the cause of permanent blindness worldwide come 2050.
So why do children become myopic?
Yeah, that's actually the biggest question that we want to answer. We still don't know exactly, but it's probably a mix of different environmental and genetic factors. For instance, we know that time spent outdoors is protective against myopia. And the more children spend time outdoors, the less prone they are to develop myopia or to have an onset of myopia.
So if sunlight is important, what are the components of sunlight that you were studying?
So what we were interested in is the spectral composition of sunlight. And our question was, if we have indoor lights that can mimic the spectrum of sunlight, can we actually use these to prevent the development of myopia and promote the phenomenon of emmetropization? So we collaborated with a company in Korea called Seoul Semiconductor, who developed these type of lights, lights that mimic sunlight. So as you can see on this graph, compared to a standard fluorescent light, the red trace that has a spiky spectrum, the spectrum of sunlight is usually quite broad and covers more wavelength. So they developed these LEDs to mimic the spectrum of sunlight, either in the morning or in the afternoon. That's around 4000 Kelvin, SL 4000, or at noon, which is the dark blue line, which is SL 6500. Yeah.
Okay.
Yeah.
And you had chicken studies, so what happened then?
So yeah, we decided to evaluate these lights on chickens. So we had 3 groups of chickens. The first group was exposed to fluorescent light. The second group to sun-like LEDs around 4000 Kelvin, the same correlated color temperature as the fluorescent light. And the third group was exposed to sun-like LEDs at 6500, which actually mimics sunlight around noon, as I mentioned earlier. So what we did with these chickens is we made them myopic for 14 days.
Oh, how did you do that?
So how do you make a chicken myopic? Well, you put a diffuser on the eye, and naturally when there's a blurring of the image and the loss of contrast of the image on the retina, the eye tends to increase its axial length, which actually is what happened in myopia in general.
Oh, yes, that's right. And how quickly will these chickens become myopic?
So that eye that was form deprived became myopic in around 1 to 2 days.
Oh,
but we
okay.
kept the diffuser for 14 days on that eye. And then after 14 days, we removed the diffuser and watched how the eye, the form deprived eye, or the previously myopic eye, recovers and how its parameters or how its ocular parameters recover and become similar to the control eye that had no diffuser on it.
That's fascinating. What did you find?
So this is our main finding. What you can see on this figure is a plot of the axial length of the eye as a function of the days of the experiments. And what you see in dark and black lines is the control eye, the eye that wasn't myopic or that didn't have the diffuser on top of it. In panel A, what you see is the eyes of animals exposed to fluorescent light. B, the animals exposed to sun-like LEDs at 4,000 Kelvin. And then at C, the animals exposed to sun-like LEDs 6,500. Now, the first thing you would notice is that by day 14, the axial length of the form-deprived eye still increased regardless of the lighting condition. So compared to the control eye in black, the red, light blue, or blue traces still showed an increase in axial length. Now, when we removed the diffuser on day 14 and let the eye recover, what we noticed was that eyes exposed to fluorescent light didn't recover to the same axial length as the control eye as compared to eyes exposed to sun-like LED 4,000 or sun-like LED 6,500. So in other words, eyes exposed to these sun-like LEDs recovered faster than the eyes exposed to fluorescent light.
So what does all this mean?
So in conclusion, our study shows that moderate levels of continuous full-spectrum LED lights that mimic sunlight can promote recovery from form deprivation myopia and maybe promote emmetropization.
Okay, so were there any limitations that you saw in this study?
So while we believe that the tuning of the spectral composition of indoor white light can offer a passive strategy to prevent myopia onset, our team is working on this. Other teams in the world are also showing the same results. Unfortunately, from our study, given that it was done in chickens, we still have a few things to do before we can say that it can be applied to humans. We probably need to replicate these findings in non-human primates, but also run a clinical trial to be able to confirm that sun-like LEDs are useful for the prevention of myopia.
Yeah. Oh, that's very interesting work, Raymond. Thank you very much for explaining it to us.
It's my pleasure. Thanks for having me.